same one.
Same
He
one.
did a lot of things.
Yes.
Oh, I see. So that's what I wanted to say.
But what was the negative aspect of this, by the way, that I said earlier?
Because too much of radiation.
Radiation dose was high, and also
The gross
the image was really, really bad. It was very dim. So they needed to come up with something that would brighten up the image, which led to the image intensifier being introduced in the 1950s. And so that really brightened up the image, and it also made it possible for us to view the image indirectly. So we didn't have to stand in the path of the X-ray beam anymore just to see what was going on. So if you take a look at this image, he's literally standing right in the path of the X-ray beam with his little special glasses to see the X-ray. So the invention of this allowed us to be away from the path of the X-ray beam.
But ma'am, where is the X-ray beam coming where he's standing?
Up through here.
So the machine, where's the X-ray, sorry, tube, ma'am, sorry?
What?
The X-ray tube?
Yes. So it was coming up through here,
Oh, that's.
and he would stand in the path to view it. Some more images of standing in the path of the X-ray beam. So you would literally, like for example, this image, the X-ray tube is down here at the bottom. X-rays would come up. You would literally have to stand in the path of the beam with special goggles to be able to see what was going on. So people were getting exposed to crazy amounts of radiation. And on top of that, the image was very, very dim. So imagine the amount of time they were doing this just to see what was going on. So the image intensifier was invented when? 1950s. And what sort of positive contribution did it do?
Right, not good.
Yep. And also, you didn't have to stand in the path of the X-ray beam. Yep.
And lead wasn't discovered to attenuate by this point?
I don't think so, no.
Their children were fried.
Alright, so you guys know what a typical fluoroscopy unit looks like. And where do you think is the image intensifier? Right there. So this right here is the image intensifier tube. Right on top of the patient's table. Okay. Alright, so this is the fluoroscopic imaging chain. Try to memorize this. So we have our X-ray tube underneath the patient or above the patient?
Underneath.
The patient. Okay, we have some collimators. X-rays come through, interact with the patient. We have a scatter grid. We have our image intensifier. We have some optical coupling, and then finally the video camera that communicates with the TV where we're able to see what's going on.
So if you have the definitions for what optical coupling and everything is fine?
Yeah, we're gonna go over that in just a second. So, image intensified fluoroscopy, what that means is basically fluoro that uses an image intensifier tube. It uses very low MA, 0.5 to 5, compared to the MA that we use in radiography, which is slightly higher. Why do you think that is?
Because
Why
the
do we
more-
have to use low MA in fluoro?
Because there are a lot of
Long
images taking place.
No.
Because taking up a lot of images, so a lot of exposure and
Yes, so you're on the right track. So because our fluoro, our exposure time is way longer because we're taking live images, we need to keep our MA low so then our mass won't be as high. Okay? So our exposure time is longer, so we need to keep our MA low and reduce radiation dose. So the fluoro unit has something called a dead man switch. Does anyone know what that is?
When you go over 5 minutes, it won't let you stop, right? Or
No, a dead man switch is basically that little eye with the plus sign that lets you take continuous imaging.
oh, you just keep going.
Mhm.
Yeah, that's the shot.
Yes. And And in fluoro, we do have a backup time of
5 minutes.
5 minutes. When you guys hear the x-ray time has been used up, you hear a beep. And the continuous beam that we get in fluoro is used, or is by a dead man switch.
So that's the name of what?
Just that pedal that we use in fluoro to keep the continuous fluoro going. So as long as you have your foot on that pedal, it's going to keep going, and then releasing the pressure terminates radiation exposure.
So
So you remove.
Yes.
So dead man switch, if dead man referring to that he's dead and just move or
No.
No, don't make it complicated. It's just the
Just
name
the
of the
name.
switch.
When you hit your foot.
it's what allows you to irradiate the person.
Yes. So true or false? C-arms are the same as a fluoro unit.
See, I'm serious for.
It is. It's a mobile
Yeah,
fluoro
'cause
unit.
yeah.
Because it does the same thing, right? So it still has our X-ray, it has our image intensifier tube, so it's basically a mobile fluoro unit. And this is what? The
Pedal. The dead man switch.
Dead man switch. Yep.
That's a dead man.
It doesn't mean that a man is going to be dead when you
No,
use
meaning
it.
that you're not, that's not what I said. I said referring to
I was
why
joking.
would you say dead? Meaning that somebody doesn't move it and it's continuous.
They dead. That means don't stay on here too long.
Mhm.
I mean, you could step on it for like 10 minutes and maybe they'll get worse.
All right. So we're gonna get into detail about some of the parts of the image intensifier tube, but I just want to reiterate, we have X-ray tube, patient table, we have the patient. X-rays come up, interact with our image intensifier. We have our video system, one for spot film, just for that still image. And then we have cine camera, which is for the movie or the X-ray that's able to move. And then we have our TV camera, which leads to our image being displayed on the TV monitor. Okay. So the whole purpose of the image intensifier is to increase the intensity of the light that comes in through the tube. But before we go into that, just know the 5 basic parts of the image intensifier. We have the input phosphor, which is this yellow layer right here. Then after that, we have the photocathode, the green layer. We have some focusing lenses on the side, also known as the electrostatic lenses. And then up here we have the accelerating anode. And then finally we have the output phosphor layer. So if I had a question, which part of the image intensifier is closest to the patient? What would be your answer?
Input phosphor.
Input phosphor, good. So the entire image intensifier tube is about 20 inches long and about 6 to 23 inches wide. So the input phosphor, that is a layer that faces the patient and it absorbs the remnant beam. What do we mean by remnant beam?
The one that goes through the patient and.
The beam
And
that's
not- it's not
exiting the
absorbed.
patient. So the remnant beam exits the patient and interacts first with our
Input phosphor.
input phosphor, okay? And then what do we know about phosphors?
What the.
They emit light. So what happens is once it interacts with our phosphor, input phosphor, emits light, okay? And then that light, what does it do? It exposes the next layer, which is the photocathode, which emits electrons in proportion to the light that came in. So let me go back, because I know that was a lot of info. Sort of. So first we have X-rays that interact with our patient, which is known as our remnant beam, correct? Remnant beam interacts.
The remnant beam doesn't interact with the
When you have a
patient.
question, please
Sorry.
raise your hand, don't
Sorry,
interrupt.
ma'am, sorry.
Go ahead.
But I thought the X-ray, the remnant beam is the beam that is left after entering the patient, ma'am, not that which enters the patient. Remnant
That's-
beam,
that's what she
the
said.
remnant
Exiting
beam
beam.
is the beam that is exiting the patient, ma'am.
Mhm. Yes, so it is exiting the patient. Cause the
So-
X-ray tube is coming this way now, right? We're no longer going through, down to the patient. Cause fluoro, the X-ray tube is underneath the table,
What-
right?
Then not all the beams that went to the patient are exiting, right, ma'am? Only the one that are not absorbed are
Yes.
exiting, that's right.
Yes.
Am I clear with that, ma'am?
Mhm.
Thanks.
So we're only talking about the X-ray beams that have transmitted through the patient,
Yes.
right? So exited the patient, and then it interacts with the, what layer?
Input
Phosphor,
phosphor.
okay. And phosphors do what?
They
Emit light. And this light is absorbed by the next layer, which is
photocathode.
photocathode. Anyone lost? I see some blank stares. Reagan. Alright, so once the light interacts with the photocathode, it emits
Electron.
electrons in proportion to the amount of light that it received. And then once the photocathode emits electrons, it is sort of guided by the electrostatic lenses. See how they're on the side? So what it does is sort of keep it narrow and focused towards going to the anode. And once it gets to the anode, what do you think the purpose of the anode is? It accelerates it, makes it even more faster, and it interacts with our output phosphor, and the electrons are once again converted to light. So that's basically the whole process of how we get our brightness in our image formation in fluoro. Okay?
Can you,
Yes.
can you explain the lenses again? You said they're narrow to do what?
Mhm. So the electrostatic lenses,
Mhm.
or the focusing lenses, they exist on the sides, and what they do is just focus that stream of electrons to go towards our accelerating anode.
Okay, thank you.
Yes,
The anode accelerates the electron.
yes, that's all you need to know. It's called the accelerating anode, and what it does is accelerates the electrons.
And turns it back into light.
Correct. It turns back into light at the output phosphor. Okay, so we can repeat what we've said all over again. We have X-rays that exit the patient, interacts with the
Input phosphor.
input phosphor, and what happens at the input phosphor?
Gives light to photocathode.
Light is emitted.
Yes.
X-rays, light is emitted at the input phosphor. The light interacts with our
Photocathode.
photocathode, is turned into
Electrons.
electrons.
Mhm.
The electrons are focused
By the
By the anode
electrostatic
into the
lenses
outer phosphor.
to the anode, which accelerates, right?
Yes,
And to
so
the-
the electrons are focused by the electrostatic lenses, and then once they reach the accelerating anode, they are accelerated
And
towards the
turns
output phosphor, where it is converted back to light again. Alright, if you have trouble with this, come see me later.
Senior.
So,
Yes,
like, I just said, the lens, what is the lens, the electrons that have been produced at the photocathode, the lens just directs it to the anode, right, ma'am?
yeah,
The
it
lens
just
is
sort
the-
of focuses towards the anode.
Direct, focus. Thanks, ma'am.
Yes. So the input phosphor in the image intensifier tube is made of cesium iodide. So you have to remember that,
Cesium iodide.
cesium iodide. So cesium is the phosphor, it absorbs the X-ray energy and converts it into light. And then our light interacts with our next layer, which is our photocathode. That is made of cesium and antimony. Antimony is the sort of silvery white metal. So the photocathode is made of cesium and antimony. Okay?
Can you spell that word?
Antimony.
You said that's the,
Antimony.
photo- photocathode?
Antimony. Yes, so that is what the photocathode is made of.
It's just antimony.
Cesium and antimony. And if you take a look at the, yes,
Sorry, what did you say before that?
the input phosphor is made of cesium iodide. Okay, and if you take a look at the photocathode and the input phosphor, what do you notice about it?
They're stacked onto each other.
They close to
Okay,
the
what
window.
else?
That they're the closest to the patient.
Mm-hmm.
Okay, what else? They're curved. Why do you think they're
What about they
curved?
wider than the,
So they can
Right.
spread
To
out
diverge.
the light or something?
Diverge
Spread
the
out?
light.
probably so they can.
Or
keep it in-
electrons.
Okay, so, it does need to be wider than the output phosphor, and
Right.
I'll get to that in a second. But the reason why they're curved is
Does
so
it
that
allow for
they
focus?
travel the same distance from the input phosphor to the output phosphor. So electrons travel the same distance to the output phosphor.
Ma'am,
Yes.
I need some explanation.
Mm-hmm.
I need some explanation. Input phosphor and photo, no, I don't understand what you said.
Talk to me after class.
Ma'am, please, this is what I can follow you.
But what is your question?
My question is that, what do you mean that the input what was your question? Input phosphor is bigger.
Curver, wider and curver.
No, the input phosphor is curved so that the electrons are traveling the same distance. All of the electrons that have been emitted, they are traveling the same distance.
So how can the broadness make it travel the same distance, ma'am?
It's the curve.
It's curved.
So the ones in the middle are gonna travel the same
So if
distance.
it was straight, the ones over here would have had to go at a very kind of steep angle to get to the output phosphor.
So both of them.
Thank you.
So the photocathode and input are sort of
Okay.
curved.
Thank you.
And they're trying to get to the output.
Okay.
Alright. And then the electrostatic lenses, they are negatively charged plates. So I said earlier, what is the purpose of the electrostatic plates or lenses?
To focus the
To
electrons.
focus
To
the
the anode.
electrons to the anode.
rotate it.
And why do you think they're negative instead of
Okay.
positive?
Because of the
To
repel.
repel the electrons, that's right. They're trying to keep the electrons in the center, right? So it wants to repel it. And then the accelerating anode, I said the purpose of that is just to accelerate the anode at a constant velocity. And the constant potential is 25 kilovolts at the accelerating anode.
Accelerating anode at constant velocity,
Constant potential of 25 kV.
Okay. After, so what we talking about now?
We're talking about the anode.
Okay. Repeat what you said if you don't mind, about the anode?
So what's the
I know it's
purpose of our anode?
It's accelerating.
Accelerating the anode, and
Mhm.
it has a constant potential of 25 kilovolts.
Okay.
Okay. And then our last layer, which is our output phosphor, it's made of silver activated zinc cadmium sulfide.
Oh my
Yeah.
silver activated.
Do you have these words on PowerPoint?
The words
No.
are in the textbook. Silver, that's the point of giving you the PowerPoint, John, so you're
No,
not
I'm
taking
asking,
notes.
is it on the PowerPoint?
No,
Then what's the point of the PowerPoint?
Oh,
taking notes,
Oh,
so you can
damn,
listen
dude.
to me.
I don't know how to spell these words.
that's what you asked.
That's why you have the
the
textbook.
So it's made of sodium, go ahead.
It's made of silver activated
Mm-hmm.
zinc cadmium sulfide.
Okay.
It's not that bad.
Cadmium is CADMIUM.
Sulfide?
Sulfide, yes.
SUL?
SULFID.
When we had everything in the PowerPoint, we got 19.
So the,
So output phosphor made of silver activated zinc cadmium sulfide. Silver
the-
activated zinc cadmium sulfide.
so the input phosphor is cesium iodide. The photocathode is cesium and antimony.
Correct.
Which is a
The,
silvery white metal.
output phosphor is silver
Activate.
silver activated zinc cadmium sulfide, and the accelerated anode is 25 kilovolts constant potential.
Mm-hmm. You got
Where should you
it.
get that?
And the electrostatic lenses are negatively charged.
Yes.
So they-
Electrostatic lenses are negatively charged to,
Keep the electrons in the middle for resistance.
that's all you have to know for today.
And you said 25 kilovolts?
25 kilovolts.
Kilovolts
Constant
of constant
potential.
potential. This sound like just some big words.
Okay,
Right inside of
Okay.
here, you like.
so let's go over this process one more time, just in case you were not able to understand.
All right,
So don't even look at this picture,
All right.
okay? So x-rays exit the patient, and then what?
remnant beam.
Go into the phosphor.
Interact with the input phosphor, which is made of,
Cesium iodide.
Cesium iodide.
alright, so what happens at the input phosphor?
Light
The
emitted.
light is emitted.
X-rays converted to light.
Mhm.
The light interacts with what layer,
Photocathode.
Samantha?
Oh,
Cut your card.
Mm.
it is the,
Photocathode.
okay, photocathode.
Photocathode, what happens there? The light is converted to
Oh, X-rays,
electrons. So at the photocathode, light is converted to electrons. And then the electrons are focused by the what?
Anode,
No,
or by the lenses.
by the electrostatic
The focus-
focusing lenses, which are negatively charged. And then what happens after
They
that?
reach the anode that accelerates it to the output phosphor,
So the accelerating anode, which has a constant potential of
25 kV.
25 kilovolts, accelerates the electrons towards the
Light,
last layer, which is
the
The
output
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 phosphor.
phosphor,
converting them into light again.
converts it into light again. And what's the output phosphor made of?
Oh, man.
They're activated.
Silver activated
Silver
zinc
activated
cadmium
zinc
sulfide.
cadmium sulfide.
Yes.
That's just too many words.
So just go over what we went over in class today so you don't forget it for next time.
I sent it in the group
It's a
chat.
lot of words.
That wasn't bad.
Did you, is it there yet?
Oh,